Okay, so the first thing they give us here is we have AB to the negative 2 over 2B times A to the negative 4 over B to the negative 3. Okay, so here's what I do, especially when it's multiplication. Think of it as just all of the top is a numerator, all of the bottom is a denominator, because it's all just multiplication, all right? I do not deal with my negatives like flipping them around until the very end. That's the last thing I do. I deal with my adding adding my like ones if it's a like base that I'm multiplying, subtracting if I'm dividing, and then I worry about whether I have a positive or negative that's going to flip it, all right? So if I were doing this one, I would say, well, on the top I have A times B to the negative 2 times A to the negative 4. It's all multiplication. And then on the bottom, I have 2 times B to the negative 3. When you have this, simplify the numerator, and then simplify the denominator, and then simplify top to bottom with division. So before I start dividing, I'm going to make sure I only have one of each variable. Like I'm going to make sure that I combine those A's in the top and combine those B's in the bottom before I ever try to go top to bottom here. Okay? So I am going to look at the top. Nothing can combine with the B up there, but the A and the A to the negative 4th are like bases. So remember, if you multiply like bases, you have A to the first times A to the negative 4th. You add those, 1 plus negative 4. So in the numerator, I'm going to have A to what power? The negative 3rd. And the B does not change because there's nothing to combine it with. In the denominator, the 2 can't combine with anything. But I have B to the first times B to the negative 3rd. I'm going to add those exponents, 1 plus negative 3. So in the denominator, I have B to what power? Negative 2, correct? All right. Now we're just going to take it one step at a time. I actually have a 1 here. 1 over 2 cannot reduce, can it? If this were 2 on top and 4 on bottom, I could actually reduce my numbers as well. But that can't reduce. So my numbers are just going to be how they are. I'm just going to be left with that 2. Let's look at the A. So I've taken care of my numbers, right? Now I'm going to look at my A. A to the negative 1/3. What does that tell me to do with that A? If it is to the negative power, it's going to move it, right? If you have a negative power, it's going to move it from the numerator to the denominator. And by the way, if you have a negative power in the denominator, it will move it from the denominator back up to the numerator. It flips it. Wherever it is, it reciprocates it, okay? So this A to the negative 3rd is actually going to go to the bottom in the positive. And I still have this 1 up here, 1 over 2. I've taken care of that. My A is going to move to the bottom, right? And then I have to worry about my B's. I actually have a B on top and a B on bottom. My rule says I subtract those. I'm dividing, right? So B to the negative 2 divided by B to the negative 2 should be B to the negative 2 minus negative 2. What's minus a negative? Plus a positive. What's negative 2 plus 2? 0. What's anything to the 0 power? 1. So I have 1 times 1. I mean, that's what that becomes. Becomes 1. 1 times 1 on the top. 2 times A cubed on the bottom. All right? So when you have it like this, simplify everything on top first, everything on bottom, and then worry about, can I reduce my numbers? Now I should only at this point have at most 1A on top and 1A on bottom, at most. I should at most have only 1B on top and 1B on bottom. If I have multiple variables on the bottom, I have not simplified the bottom enough. I need to keep simplifying. And when I'm finally done with this, I should only have 1 of each. My final answer should never have 2 A's in it. I have not simplified it at that point if I have more than 1A or more than 1B. Make sense? All right, so for this one, I have in parentheses, we have ABC squared, and all of that is to the second power. In the denominator, I have negative 3BC. So again, I'm going to simplify the numerator as much as possible, and then I'm going to simplify the denominator as much as possible, and then I'm going to simplify top to bottom, okay? So let's look at the numerator first. Remember, when I have a power out here, everything inside has to be taken to that power. So that means I'm going to take A to the second power. I'm going to take B to the second power. And what happens here? I have C squared to the second power. The bottom is actually as simple as it can get. I can't do anything with a negative 3. The B doesn't have anything to combine with, and the C doesn't have anything to combine with. All right? I can still simplify my numerator one more step, right? This power to a power, what do I do here when I have a power to a power? What do I do with those? I multiply them. So I have A squared, B squared, and now C to the fourth, right? Over negative 3BC. And then I'm just going to simplify. All right? You can simplify them individually. Technically, there's a 1 here. So my negative 1/3 cannot reduce. That's as simple as a fraction can get, right? What about my A's? I just have an A squared on top. I don't have an A on bottom. So nothing's going to happen to them, right? The A is going to stay on top there. Yes? Let's look at my B's. I have a B squared on top and a B on bottom, which is to the first power. That can simplify, right? What about my C's? I have a C to the fourth on top and a C to the first power on bottom. That will also simplify. Okay? So let's look. I'm going to make one. It is going to be negative because I have that one negative in there. It doesn't matter where it goes, top or bottom. Let's look at what happens here. These are the two that will simplify. Remember, I told you can tell where it's going to end up by where the highest exponent is? All right. The 1/3 is not going to change. The A squared is not going to change. Where is my higher exponent for my B's? On the top or on the bottom? So where are my B's going to end up? On the top. And I just subtract. 2 minus 1. I have B to what power? B to the first power. Where's my higher exponent for my C's? So where are my C's going to end up? 4 minus 1 is 3. And of course, I'm going to make it look a little prettier because that's kind of ugly looking. So now that I know what's going on here, I don't really need the 1. You can leave it if you want it. It doesn't matter. On the top, you have A squared, B, and C cubed. You do have that negative. And on the bottom, you just have a 3. Everything else reduced out of the bottom. All right, so I'm going to take this one at a time. Each piece in it is just like I did before, is going to be raised to a power. So I have 6 squared. What is 6 squared? 36. X cubed squared. I have to multiply those. I'm going to have x to what power? 6th. Y to the 7th squared is y to the 14th. All right, and those are all multiplied. Now I'm going to do it with this one. Negative 1/2 cubed. Is it going to first be positive or negative, by the way? A negative cubed. Positive or negative? Negative. And then I just have to worry about the numerator. 1 cubed. What's 1 cubed? 1. And then the denominator. 2 cubed. What's 2 cubed? 2 times 2 times 2 is 8. All right. Then let's do x. X squared cubed. Multiply those. X to what power? All right. And then what about y cubed? Cubed. Multiply them. Y to what power? The 9th. And now I'm just going to simplify my terms that are alike, okay? I'm going to have 36 times negative 1/8. So 36 times negative 1/8. Remember, this is over 1. Then I can multiply my x's. X to the 6th times x to the 6th. Y to the 14th times y to the 9th. All right. Here I can cross cancel, right? 8 and 36. How many times does can I take out of that? What can I take out of both of those? What goes into 8 and into 36? A 4. Yes, you're right. 2 and 9. And it's a negative times a positive. So that's going to be negative 9/2. All right, what about my x's? Like bases, so I need to do what to those exponents? So it's x to the 12th. Like bases, how many y's do I have? Y to the 23rd. And that's my answer right there. All right, so let's look at number 2 on page 336. Number 2, we have 36y to the 5th over 24y, and this is to the first power. So remember I said you can look at them individually. Can I reduce 36 and 24? No. I can. Yes. What goes into both of them? 2. Yeah, actually 12 does. You can start with 2 if you want to and work your way up. So reduce it by 2, then reduce it by 2 again, or reduce it by 3. So you can keep reducing. But yeah, 12 actually goes into both of these. So how do I reduce it? 36 divided by 12 is going to give me 3. And then 24 divided by 12 is going to give me 2. Let's look at my y's. Where's my larger exponent for my y's? On the top. So where's my y going to end up? On the top. And all I have to do is subtract them. 5 minus 1 is 4. Y to the 4th on the top. All right, so number 24, we have 38 x squared y cubed z to the negative 1. On the bottom, we have 2 x to the negative 2 y to the negative 3. All right, so let's start with the numbers. That's easy. 38, is that divisible by 2? It is. What's 38 divided by 2? 19. It's 19 over 1, and so, but we don't have to put the 1 on bottom. That's fine. Let's look at my x's. Where is my larger x, on top or bottom? Top. 2 is definitely bigger than negative 2. I need to subtract. So I automatically know my x is going to be on top. I can go ahead and put him there. Just figuring out what it is. What is 2 minus a negative 2? It's 4. Plus positive. It is plus. You are subtracting because it is top and bottom. It's division. So my exponent here is going to be 4. All right, let's look at my y's. Let's look at my y's. Shh. Where's my larger y? Top or bottom? Top. So I know my y is going to be on top. 3 minus a negative 3. 6, right? It's going to be 6. All right, z. Z is to the negative 1, and there is no z on bottom. So z is just going to move and keep the exponent, but change to a positive. Since he's on top right now with a negative, he should go to the bottom with a positive. All right? If he had been all alone on the bottom with a negative, he would have gone to the top with a positive. They just move if you're not reducing it with anything. So I don't have any numbers on the bottom, but now I do have a z. That z is going to move to the bottom to the positive 1. Remember, if it's a positive 1, you don't have to actually write it. So my final answer here is going to be 19 x to the 4th y to the 6th over z. Good? I'm going to scooch that up, and then we can do 30. All right, let's look at 30. All right, number 30. We have x squared times x squared y cubed to the negative 3. All right. So far, so good. Deal with the one that is in parentheses first. Power to a power. So I'm going to leave this x squared alone. This x squared is going to be taken to the negative 3rd. This y cubed is going to be taken to the negative 3rd. All right. Leave this alone still. Power to a power. 2 times negative 3 is what? Negative 6. Power to a power. 3 times negative 3 is negative 9. All right, we're going to bring it up here. I can combine the x squared and the x to the negative 6 because they are like bases. What do I do with those exponents? You add them. So 2 plus negative 6 is going to be x to the what? Negative 4 times y to the negative 9. I have one x and one y. They are both negative. Where are they going to go? Technically, they're on top right now, right? That would be over 1, right? Where are they going to go? When everything goes to the bottom, you must put a 1 on top. All right? You must put a 1 on top. Okay? So everything is actually moving to the bottom, which means I need to put a 1 there to indicate this is a 1 over something. And I'm going to take those both to the bottom with a positive exponent. And that's my answer. That's a 9, by the way. He just didn't look like it. There we go. All right. First, what is scientific notation? Scientific notation is when you express a number in the form a times 10 to a power, where your a is between 1 and 10, inclusive of 1, not inclusive of 10. What do I mean by that? You can use 1 as your answer, but you may not use 10. It does not include 10. If it is 10, you need to pop it one more decimal place and go back to 1, okay? So it has to be less than 10 or greater than or equal to 1, okay? It cannot be 10 itself. So let's look at what that means here when we're converting back and forth. Why do they use it, first of all? Well, because if you have a number that is, 27 digits long and you have to write it out, it's just basically a shorthand way to write a big number, or shorthand way to write a really small number, so that they don't have to write it multiple times and put all those zeros there, which are, significant, but they are not, you don't want to write them that many times. So we have this number here. We have 4,200,000. I basically say, where is my decimal right now? My decimal right now is located right here. Here's where my decimal is. In order to get that number between 1 and 10, I'm going to look here and I'm going to say, how far do I need to move it so that my number is between 1 and 10? Well, I need to move it here, so it's 4.2. All right, so 4.2 is between 1 and 10. We're good to go. How many places did I move it? Well, I moved it 1, 2, 3, 4, 5, 6 places. So that is to the 6th power. All right? If I am starting with a really big number and putting it in scientific notation, my exponent will be positive. Okay? So if I'm going from standard notation to scientific notation, and I'm going from a big number to scientific notation, your exponent is positive. All right? Look at the next one. This is a really small number. I need it to be between 1 and 10. So I'm going to move that between the 6 and the 7. Okay? Between the 6 and the 7. 6.7 is between 1 and 10. We're good to go. How many places did I move it? I moved it 5 places. Okay? I am going from a really tiny number, 0.000067, right? It's a really small number. And I am putting it in scientific notation. My exponent is negative, okay? If I had given it to you in scientific notation and I wanted it to be in standard notation, this is 10 to the 6th power. I am definitely making that number bigger, okay? So that means I need to add decimal places to this guy. 4.2, I need to move the decimal place 6 places to make the number larger. If I moved it to the left here, that would have made my number smaller, right? So if I'm going from scientific to standard, this tells you, is my number going to get bigger? Positive exponent is going to be a bigger number. Negative exponent is going to be a smaller number. All right, so let's just look at rewriting them. Express the number in scientific notation. All right, let's look at the first one. My decimal is here. It is a really big number. So my exponent is going to be positive, however many places I have to move it. I want to move it over here in between the 2 and the 9. So it's going to be 2. My decimal is going to be here, 0.95. How many places did I move it? 1, 2, 3, 4. It should be 10 to the positive 4. Look at the next guy. Where am I going to have to put my decimal to make it between 1 and 10. Where's the decimal going to go? Between what two numbers?
4 and 3.
The 4 and the 3. So I know it's going to be 4.3. How many decimal places did I move it? I moved it 8, by the way. But 1, 2, 3, 4, 5, 6, 7, and I moved it right here, 8. It was a tiny number, so that is to the negative 8th power. Easy.
So if you move it back, it's negative.
So now we're going the other direction. They want us to write it in standard notation. All right, express each number in standard notation. I am going to start with that 2.1, and it is times 10 to the 5th. Should I end up with a really big number or a really small number? A really big number. So I should be adding zeros to this guy, making it larger, not adding zeros in front of a decimal. Okay? So I am going to make this bigger, which means I'm going to have to do this 5 times. All right? Fill in the blank with zeros. 1, 2, 3, 4 zeros. All right, and then you're going to need to take your decimal away when you are doing scientific notation, unless you have so many numbers that you don't have a decimal, that you still have a decimal. All right, so I'm going to say, here's my number. I need a comma there. 210,000. All right, look at the next guy, 6.8. That's what I'm going to start with. This is negative 6. Should my answer be really small or really big? Really small. So I'm going to move my decimal the other direction, so that I'm really small. So 1, 2, 3, 4, 5, 6. I need to leave this decimal right here, and I need to fill in the blank. 1, 2, 3, 4, 5, right? So you're going to have the same number, one less than what you had there. So my answer here is 0.000068. Yeah, so like, for this one, you're gonna obviously see that 3.9 is where you're gonna go, and then you're gonna count your digits is 8. This guy was not in scientific notation. Why is he not in scientific notation right now? This one, rewrite this piece in scientific notation. I need to move my decimal place over 1. 1.36. I moved it over 1 times 10 to the 1st. Times 10 to the 7th. So I just rewrote this piece right here to be that. Everybody see that? And then you can use properties of exponents. Yeah, so we're going to do one more step. These are like bases, aren't they? 10 and 10 are the same base. So what do I do with my exponents when I'm multiplying like bases? You add them, 10 to the 1 plus 7. So my answer ends up being 1.36 times 10 to the 8th. Right? I took this 13.6 times 10 to the 7th. I moved that over 1 time, which means I had to add 1 more to that guy. So 1.36 times 10 to the 8th. All right, so this one they wanted in standard notation. Your number should have gotten bigger. So you should have gotten 254 million. So even though it's in scientific notation legitimately says times 10 to the whatever. So you're basically saying 7.5 times 10 to the negative 5th times 2 times 10 to the 3rd. Like this is what you're saying here, okay? Which means I can rearrange it, right? With multiplication, 2 times 3 is 3 times 2. It doesn't matter what order I multiply in. So I can multiply the 7.5 and the 2. And then I can multiply the 10s. 10 to the negative 5th times 10 to the 3rd, right? What is 7.5 times 2? So I have 15. These are like bases. So what do I do with the exponents? I add them. What's negative 5 plus 3? Negative 2. Now, I do want my answer in scientific notation. Is that scientific notation? It is not, because it's a 15. So this 15, I am moving it 1 decimal place. My number is bigger than 10 originally. So moving it 1 decimal place, I need to add 1. It's positive. So negative 2 plus 1 is negative 1. Everybody see that? Yes? Power to a power. Look at the next one. I have this whole group to a power. I'm multiplying something and I'm taking the group to a power. Everything in it has to be taken to the power. All right? So it's a decimal, but it's 12. What's 12 if I square it? 144. I started out with 2 decimals, so 144 with 2 decimals is 1.44. I'm just showing you how to actually square that decimal. 1.2 squared is 1.44 because 12 squared is 144. And I had 2 decimals, right? This next piece, power to a power. What do I do with those? So -4 times 2 is -8. We're done with that one. That's already in scientific notation, so. So another way to look at this one is to say 2.4 times 10 to the 7th divided by 6 times 10 to the 2nd. I can just divide my numbers and divide my bases. 24 divided by 6 is what? What's 24 divided by 4? So what is 2.4 divided by 6? It's going to be 0.4. 0.4. All right? I am dividing like bases. What do I do with my exponents? Subtract. 7 minus 2 is? So I have 10 to the 5th. I will say, scientific notation is the only place where I'm going to let you leave negatives in your exponent because that is accurate for scientific notation. 10 to the negative something is fine. I don't want it 1 over, okay? In this case, it's positive, but just FYI. Now, is this in scientific notation? No. What do I need to do? Move it 1 decimal. This is smaller than 1, so I need to subtract 1, right? It would be a negative movement there. All right, so this is going to be times 10 to the 4th. Does everybody see what we're doing here? All right, so I want you to try some of these. Or one of them, I guess. They want us to simplify. This is addition. Okay. Obviously, you can change it to standard notation and add if you want to, but they actually are showing you a way to do it without transferring it from scientific notation. So let's look at this first one. If y'all remember the distribution concept, all right, distribution concept. If I have a number on the outside, it's the same thing as multiplying it through, okay? And it works the other direction. If it's inside, you can take it out if it's in both of them. So if this is, and I'm going to look at this like a bracket here. I have the same thing in both of these groups. What is it? 10 to the 6th. So I can take that out. And what I have left is the 2.3 plus the 5. Does everybody see that? So I can just add those. That's how we actually did like terms, is when we did like terms. What is 2.3 plus 5? 7.3, right? Now, this is 10 to the 6 times 7.3, but that's actually not how it looks when we write it in scientific notation. So if I want to write this in scientific notation, I'm going to say 7.3 times 10 to the 6th. That one's not bad. Looks good. These do not have the same exponents. All right, so we have a little bit of a problem. We have a power and a power that's not exactly the same. And so they show it by changing one to a negative and taking it out that way. And I actually think you lose a little bit when you do that. So when you're factoring these, you can only take out the lowest exponent. So I'm going to look at this bracket here, just like I did before.